This is thermography, which is actually the fancy name for thermal imaging. My name is Lauren Warner, and before we get into thermography, first we must discuss light, or more accurately, energy. There's this thing called the electromagnetic spectrum. It goes from 1/10,000th of a nanometer to 100 meters. We have gamma rays, after that X-rays, sunshine in the form of UV light, and then of course, rainbows. Actually, this portion, while it does create the rainbow, is called visible light. But most importantly of all, at least for thermography, is infrared, which is then followed by radio waves. Infrared means below red, because if you look at the spectrum, it's kind of like right below red. However, what most people would call it is heat. The question, of course, is how we get from this infrared light to thermal imaging. And the answer is thermal cameras. These take an image of, say, a fire, and change it into one of those pretty images with all the colors. And what do we need to do this? Code! Literally color coding it. That's how an image of a human and a desk becomes red and orange and blue and purple. And the great thing about it is that it doesn't need light to work, just heat. Thermal cameras can measure anything from -20 degrees Celsius to 2000 degrees Celsius. To give you an idea, fire ranges from 800 to 1200 degrees Celsius. So the question now is, why? Why do we care? Why use it? So let's go back to fire. Or more specifically, the people who fight them. Firefighters. I've actually been working on a way to make thermal imaging more readily available to firefighters by incorporating it as a heads-up display in their air masks in order to allow them to put out fires more efficiently and to stay safe. Others include ghost hunting? I don't know. But military use, of course, and also finding insulation leaks or burst pipes, among many, many other choices as well. So really, why not? It's fun, it's cool, and it's science. The end.